Bismillahirrahmanirrahim. Okay, dear listeners, now we are going to perform the step number 5 of our RNA-Seq differential expression pipeline. So in this step number 5, this is called, in which we are going to do is just counting of number of expressed transcripts. So we are going to count number of expressed transcripts in our data. So in the previous step we were in Trinity, and let's see what are the different folders in this working directory. So you might remember that we performed the last step in the util folder. So let me go into it. cd util. So look into here. Okay, so here we generated three files, and for this step we are going to use this file for further usage. So this is the file that we are going to use for this step number 5, that is just a counting of the number of expressed transcripts. So for this purpose we have to move this folder, this file, we have to move this file, we have to move this file into this folder. This is the folder MISC. It's a miscellaneous folder because the script we are going to use, that is present, that is placed in this folder. So I'm going to move our input file into this folder. So we will just write here MIS. So it's auto completed. So what I'm going to do, that I'm going to move this file Burberry_Pashmina.isoform_tpm .not cross norm into miscellaneous folder. So you can look here that this file is not here, so that is into the miscellaneous folder. So I have to go into the miscellaneous folder now, cd miscellaneous. So just look into here. Here is a lot of scripts and the files are here, and our file would be definitely starting with B. So yes, this is the file that we just moved here. So Burberry_Pashmina isoform_tpm. So this is the file, that is the input file that we are going to use here. Okay, so here is the command that we are going to use. I will let you know that command, that is a Perl script. Yes, this is the script. So write down the per and then this count underscore matrix feature given minimum ppm. So this is the written script here, starting with the count matrix features. So this is the script, this is the script, count matrix feature given mim tpm, and this is with the extension .pl. So this is a Perl script. So what we have to do now, so this is the definitely we will copy it. So this is the script we will copy it, and then how we write it here. So this is per, and then we will paste this script which is present in the present working directory in the folder. Okay, so this is, and then we will give the input files. So this is the Burberry underscore Pashmina isoform TPM not cross norm. So this is the input file, and then we will use the pipe. So normally we use this pipe that we don't want the output of this command, rather we want to use this command, this pipe, to process that input file in the further command. So here is the argument TEE, and then we will give the name of the output file. So I'm using Burberry underscore pash dot tpm underscore count. So this is the file that will generate after the successful completion of this command. So let me give you an idea. Let's cross check it. The per, then count matrix feature given min tpm threshold per. So this is the Perl script that we are going to use, and then we are giving the input file that we generated in our previous step, and make sure that this is a TPM not cross normalized. So this is not the normalized file, TPM file, but this is not normalized form, normalized file. So now we are going to normalize our this file with the help of this script. So when we just run it, so it will create a file with the name bar underscore pash tpm and count, and make sure that TPM is abbreviated as transcripts per million, and the transcripts per million is one of the method for the normalization of RNA-Seq. So we are going to normalize, and let's see when we just run it. I have already ran it before, so we will generate a file with the name this one. So I have already done it with, so I will show you the file that we have generated after the successful completion of this command. So here is the file. Here is the file with the, yes, so this is the file that you will have after this after the completion of this file. So this is a 7.2K of size, and Burberry Pashmina. So this is a file. So let's go into the file and look into here. Let me copy it first. So this is the file, copy it, and then we can use nano editor to visualize this file, and then paste it and enter it. So this is the file that is having two columns. One is minimum TPM, and second column is number of features. So this is the TPM values. These are the TPM values, and these are the number features mean number of transcripts. So when you look deeply, so it's showing that with the TPM minus 65,961 TPM, at least at this minimum number of the TPM, at this TPM only one transcript is expressed. So as you can look into here, that as you will go down, I mean the higher TPM value, the number of the genes are also increasing. So let's go down, so you will have the value like in this way. So you can look at here that yes, so just look at here, like if you are giving 1 TPM, so at 1 TPM there are 25,847 transcripts, those who are expressed at this TPM. And similarly, if you look at the 5 TPM, so you are giving more stringent situations, that at TPM 5 there are no, that is going to be more stringent. At 5 TPM, like -5 means now we are giving very low TPM. So at very low TPM there are 14,713 genes, other transcripts are expressed. So very stringent conditions of the TPM, there are very few genes or the transcripts are being expressed, while if you are not so stringent, like in case of 1, so there are maximum number of the genes those who are expressed here. So this is just giving you an idea that at very stringent conditions, at very strict conditions of the TPM, there are very few genes are expressed. But if you are you can say if you are making your conditions less stringent, so there are more genes which are expressed. So in our case 25,847 transcripts are expressed at 1 TPM. And similarly, if we are giving the more stringent conditions, the number of the genes those who are expressed, they are also becoming low. So let's this is counting of the expressed transcripts. So Control X, we will come out. So now we can also draw this matrix, that is a number of the TPM, that is TPM on the first column, and then in the second column we have number of transcripts. So we can also we can also plot of this matrix on R. So make sure that you have R already installed, and let's go to the R for plotting this matrix. Okay, so this is the R, as you have already installed R in the in previous steps. So here I want to plot like import dataset. You will choose the first option, that is from text base. Okay, so we will go where this file is present, so that is in our hard drive, then in RNA-Seq data, and then in the Trinity, then we have our file in utils, and then in the miscellaneous, and here should be our file named this one. So this is a bar pashmina TPM count. So this is the file I want to open in R. So just select this file and open. So you will have this file in R. Just complete the name of the file. Okay, so just import this file, import, and you will have your file uploaded on R. So it will also appear here, and this is the same file that we already visualized on the Linux. So this is -_minimum_TPM transcripts per million, that I have already told you that this is one of the normalization method of the RNA-Seq data, and this is num underscore feature means number of the transcripts. Okay, so we want to plot, we will use plot, and you will write the name of the file, that is bar, yes, autofilled, and then we will use xlim is equal concatenate, that would be, okay, I have already ran this command. Let's go and see. Okay, so plot, and then this is the file bar. Okay, then we will use xlim is equal concatenate, and the value would be, our x value will be from -100 to 0, then comma, and then we will use ylim is equal concatenate, and the value would be here for the y-axis from 0 to this value 100,000, and then you can use okay, so you can also use, okay, let's see, try here. So we are going to plot this file, this is the input file, and then the x limit is a c concatenate, these are the x values and these are the y values, and okay, so just enter it. Okay, yes, so here you can see that our this is a value from -100 to 0. This is what I used here for the x axis, and on the x axis we have a minimum TPM value, and on the y axis we used from 0 to 100,000 number of features. So number of features being transcripts. So we approximately used that there might be 100,000 transcripts. So you can look at here that most of the transcripts, they are having very low value, near to 0. So they are most of the genes, they are having very low TPM, as like these are the number of the transcripts. So very low transcripts, most of the transcripts, they are having very low TPM, but at the end of the plot you can look at here that as the number of the TPM is increasing, so there are very few transcripts, those who are having those who are expressed at very high TPM. So this is just a plot that is showing you that there are very few transcripts, those who are expressed at very high value of the TPM. So this is what we want to count in this step, and this is just a normalization method, and we can have that how many genes are expressed and what are their count against very stringent TPM and very low TPM value.